All right, so last thing I wanted to do was just go through how you could work through the second part of the lab, where it asks you to deal with a situation that looks like this, where we have a charged particle, it indicates the equal potential values, and then we have, I believe it's an electron that is moving off into infinity, right? And it asks us to find what's the final velocity, or how fast is it moving after it moves away. And so what we can do is we can use our equation, and as long as we know our charge and we know our initial and final electric potentials, then we can figure out how fast it's actually moving. We can do that because if my initial voltage here is 10 volts, the final voltage here, if there's really no other charges, because we're using the equation, it's a point charge, right? So our potential is going to be K Q over R. Well, as I get farther and farther away, this value is going to get essentially 0. So my final voltage, we can say, is 0. Right? So then I can use the idea of my change in potential, which in this case is going to be a gain of kinetic energy is going to equal Q times 10 volts. That's the change in voltage that I go through. Okay? So again, I could set up 1/2 mv squared Q delta V, and I can solve for V using that information.